Alright, this is Chapter 2, Part 2, 2-3, Limits Involving Radicals. So, limits using radicals. It's supposed to be a D. Limits using radicals, such as the square root, or even the cubed root, etc., can't be solved with factoring. You must use rationalizing. For instance, if you remember from Algebra 2, to rationalize a denominator such as 1 over the square root of 3, you would multiply the top and the bottom by the radical in the bottom. And that would give us 1 times the square root of 3, which is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9. So to get the radical out of the bottom, you would take the square root of 9, which is 3. So the answer would be square root of 3 over 3. Now let's apply this to limits. Say I wanted the limit as x approaches 1 of the square root of x plus 1 minus the square root of 2 over x minus 1. If we plug in 1 here, we're going to get the square root of 1 plus 1 minus the square root of 2 over 1 minus 1, which is the square root of 2 minus the square root of 2 over 0, which is 0 over 0. Uh-oh, we can't have that. Right? We can't have that. So what are we going to do? Well, here's what we have to do. In order to take the limit of the square root of x plus 1 minus the square root of 2 over x minus 1, we have to rationalize our limit. So what we're going to have to do is we're going to have to multiply by what's called the conjugate. It's a complicated sounding word for something that is fairly simple. All you do is you look at your two terms, you take the sign between the two terms and flip it. That's all you do. So we're going to be multiplying by the square root of x plus 1 plus the square root of 2 now. And we're going to do the same thing to the bottom. X plus 1 plus the square root of 2. Alright, now you're simply going to FOIL it out. So the square root of x plus 1 times the square root of x plus 1. When you multiply a square root by the same square root, the square root cancels out, leaving you x plus 1. And then you're going to have the square root of x plus 1 times the square root of 2. So square root of 2, I'm going to write that first. Square root of x plus 1. And then now negative the square root of 2 times the square root of x plus 1. And then negative square root of 2 times the square root of 2 is negative square root of 4. Alright, over x minus 1 times the square root of x plus 1 plus the square root of 2. Alright, now let's get some of that mess out of the top. So this is going to go to the limit as x approaches 1 of x plus 1. This and this cancel out. The square root of 4 is 2, so this is going to be minus 2 over x minus 1 times the square root of x plus 1 plus the square root of 2. Alright, now x plus 1 minus 2 is simply x minus 1 over x minus 1 square root of x plus 1 plus the square root of 2. Now as you can see here, this and this cancel out, leaving you with 1 over the square root of x plus 1 plus the square root of 2 Now you can use direct substitution to plug it in. You're going to get 1 over the square root of 1 plus 1 plus the square root of 2, which equals 1 over square root of 2 plus the square root of 2, which equals 1 over 2 square root of 2. That would be your limit. Now, you would normally have to rationalize that, but for the sake of this, I'm going to let you leave it. All right. Now, let's look at a kind of a shortcut way to do this. All right. Let's look at kind of a shortcut way to do this to make this a little bit faster. Let's do the limits of the square root of x plus 4 minus 2 over x. All right. Here's the shortcut way. All right. Since we're rationalizing the top in this case, what you're going to do, all right, let's draw a fraction bar over here. You're going to take this number right here. All right, you're going to take this number right here. If it's negative, make it positive. If it's positive, make it negative. Although it should be negative, because if it's positive, it won't work out in the denominator later. So take this number, bring it down to the denominator, and multiply it by 2. So 2 times the number. 2 times this number. So 2 times 2 is 4. And you're always going to have a 1 up top. 1 up here always. You're always going to have a 1 up here, and the bottom will be 2 times this number. All right, in this case, we're doing x approaches 0. All right, so you're always going to have 2 times this number in the denominator. All right, you're always going to have 2 times this number in the denominator. All right, so if we go back to our previous problem, all right, if we go back to our previous problem and look, if we do that same thing, the limit of the square root of x plus 1 minus the square root of 2 over x minus 1 as x approaches 1, this is going to equal, put our fraction bar, a 1 always in the top, take this number, since it's negative, we're making it positive, put it down here, and multiply it by 2. Well, when you multiply it by 2, it does not become the square root of 4. What it becomes is 2 times the square root of 2. Well, if you look, there's our answer we did doing it the long way. Here's our answer we did doing it the short way. Do they match? Yes, they do. So that is your shortcut. You can remember the shortcut. You're more than welcome to do it the long way. I would remember the shortcut if I were you. All right? I would remember the shortcut if I were you. Let's work this one out the long way real quickly just to make sure that it matches. Limit of the square root of x plus 4 minus 2 over x. Remember, you're going to multiply by the conjugate, which is simply changing that sign. Square root of x plus 4 minus, plus 2 over x. Square root, I'm sorry, that x doesn't belong yet. X plus 4 plus 2. And this equals, remember, this times this. You cancel out the square root, x plus 4. And then just like with normal FOILing, when you have a negative and a positive in the middle term cancels out, leaving you minus the last terms multiplied, so 2 times 2 is 4, over x times the square root of x plus 4 plus 2. Now, we can't cancel the x's yet because it's involved in addition and subtraction. But if you notice, this and this cancel out, leaving you with only the x on top. Now the x will cancel with the bottom, leaving you with a 1 on top, and the square root of x plus 4 plus 2 in the bottom. Remember, this is the limit as x approaches 0. So plug in the 0, you're going to get 1 over square root of 0 plus 4 plus 2, which equals 1 over the square root of 4 plus 2, which equals 1/4, because this comes down to 2 plus 2, which is 4. So here's the answer we got the long way. Here's the answer we got the short way. Do they equal? Yes, they do. So you can remember the long way, or you can remember the short way. The short way will save you a lot of work. All right, so I would remember the short way. So for this video, I'm not going to give you a ticket in the door. Just make sure you go through this video, make sure you understand this process, and take some notes on it, write them down. Remember the process. Remember, all you're doing is multiplying by the conjugate of the top, and the conjugate of the top is simply the same thing. You just change the sign between the terms. Between the terms. Not in front of the first term, but between the terms. All right? See you tomorrow.